the questions in the quiz. Because there's some people I notice who are 100% convinced that they got the right answer when they actually got the wrong answer. So it'll be good for you to see the questions done at 11 when we're all together. But for this class now, this tutorial, we'll stick to the book for the moment, and whichever questions you would like to practice from the book. Page 50. You sound like you have something in mind for sure. That's okay. Which one?
3y.
3y. Okay, let's have a look at that one. Page 50, 3y. We have 9 power x minus 12, 3 power x plus 27. Now, is my answer wrong, do you think? Is this possibly it, or?
No.
You're
right.
You're stumped.
I messed up somewhere.
Okay. What should I do first here? Does anybody have any ideas? 3 squared, yeah. I should change this to 3 squared x minus 12 3x plus 27. So this becomes 3x squared. Huh? Is it okay? 12 times 3x plus 27 equals 0. This is a quadratic. Does it have factors? I think it does. I think its factors are like 9 and 3. It's a quadratic with 3 power x as the variable. Minus 9 and minus 3. So let's see, we get 3x equals 9 or 3x equals 3. So either x is 2 or x is 1. So what went wrong for you, Mo?
My factors.
Yeah. The factors. Don't you have a graphing calculator that does this for you?
But the power thing messes it up.
No, it doesn't. No, Mo, listen. You could have just typed it in on your graphing calculator as x squared minus 12x plus 27.
That's what I did. It doesn't show that.
And what did it say the factors were?
Okay, so 1 minus 12 and 27.
Yeah, what factors?
It's just error.
Error?
Yeah.
Error?
Yeah.
Something's wrong with your calculator.
I don't know. This is why I got confused.
Because look, if I put on this calculator, 1 minus 12, 27.
Oh.
Is
I'll figure it. There's something probably wrong. Figure it out.
Maybe you need an update patch or something. Has your subscription expired? Yes. Okay, what do we need to see next now? Page 50 again? Yeah. Which one? Which one? 5C. Okay. So just in a moment now, once people write this down. And number 6. Okie dokie. You have no notes in front of you. Are you a genius that you don't need to make notes? Or maybe not. Did you write this down over here? Yeah? Mo?
Yeah.
Yep, okay. So, sorry, what are we doing next?
5C.
5C. Okay. Same page, 5C. Alright. 5C. So, we have y equals 1 plus 3e power x, and y equals 7 minus 2 over ex. We want to know where these curves meet. I should make them equal to each other, because they're both equal to y. So I get 1 plus 3ex equals 7 minus 2 over ex. Is that okay so far? What do you think I should do next? times everything by EX, yeah? So that's EX plus 3E2X equals 7EX minus 2. So that's 3E2X minus 6EX plus 2 equals 0. Because I take everything to the left. Yeah? No? What's the problem? 1EX minus 7EX is 6EX. 3E2X is already on the left, and the minus 2 comes over to become a plus. Is it okay or not okay?
Yeah.
Are you sure?
Yeah.
Okay. So, what type of equation is this? Quadratic. Does it have factors? No factors?
So this is why I had a problem in this step. We cannot take the square out, right? Because three we would have to get the root, right? Otherwise, with 3x, if we take it as square outside, ex.
No, we can take the square out. We could write like this: 3EX squared minus 6EX plus 2 equals 0. That's fine.
Because in our school they said we cannot do that. You would have to take the root and put the square outside.
Are you sure? Are you sure your school said that? Because that would be wrong. Yeah? What did your school say you had to do? You had to take...
We didn't have any 3. We would get usually 9 and then it would be 3ex the whole square.
Slow down, man. Slow down. Give me an example.
9 ex square. So
Square on the whole thing? Or
if it was e2x.
like this?
Yeah, instead of taking it this way, our school would say 3ex the whole square. 3ex the whole square.
But that is true.
Yeah,
Yeah, but it's also fine for me to write this.
okay.
These aren't opposites. These are the same.
Yeah.
Because if the square goes in, it comes back to this. And if the square goes in on both of these, because the brackets, it goes back to this.
So we can use that step since we don't have to take the coefficient inside.
You can, but you don't. Okay, because the reason you don't is if you did that, look at what would happen. You would get this. You would get root 3EX squared minus 6EX plus 2. Now, why is this bad? Well, what's the problem with this guy? Yeah, what's wrong with this?
Aren't you supposed to square the whole thing?
No, what's wrong with this?
It's not quadratic.
It's not quadratic anymore, because these are different variables. Because this is no longer the same thing as it is in the previous. So anyways, what do we get? EX equals minus B plus or minus square root B squared minus 4AC. 24, is it? EX equals 6 plus or minus root 12 over 2? You're giving me the simpler version. What is it?
3 plus over 2.
Like this?
No, all over.
All over 3. Oh, sorry, that's a 6, isn't it? Sorry, yeah. What the heck?
Isn't your a variable, yeah?
Sorry, yeah, that's a 6 there, isn't it? So it's 3 plus or minus root 3 over 3. Is that what you're saying? Yeah. Good. So finally, x equals what? Log 3 plus or minus root 3 over 3. Okay. Who was asking me for that one, actually? Yes, Colin. What one, yeah?
Finish off 6Q.
Which page?
52.
Oh, 52.
No, on the same page there's number 6 as well, the sequence.
You want to see number 6?
Yeah.
Okay. Then we'll do page 52. Okay, are we ready to see the 6 on that page? So, can I scroll down? Yep, okay. So I say you have the sequence CEK, CE2K, CE3K, and I ask you to show that it's geometric. So, okay, it doesn't matter if it's arithmetic or geometric. The first term is the first term, which is CEK, isn't it? So actually, I suspect now I've done something wrong here. No, I haven't. Okay. First term is the first term, and that's the first term. What's a little bit harder, perhaps, is to see what the OR is. So we should get the same answer if we do second over first. That should be exactly the same as if we did third over second. But it is. So these C's cancel. Yeah. So it's EK, and these C's cancel, and it's E3K minus 2K, which is EK. So clearly OR is EK. So we're finished. We have UN equals A or N minus 1. That's the A, and that's the OR.
So we're not supposed to solve it. Okay,
Yeah? Page 52? Which one? Which number? 6Q? 6Q. Next page.
So I have a question.
Yeah.
Question. You asked us to find what they are defined in, so we have to know what x can be greater than what. And how would you know that? You just
Well, let's have a look at Q as an example. Yeah? Can I scroll down? Yep. Okay, so next page. 6Q on 52. What have we got? We have got log base 7 1 over x plus log base x 7 equals 7. Now, as Mo was asking me, first thing you have to figure out is where is the x defined? So in other words, what values of x can you use in the equation? So having a look at this equation, there's one obvious no-no for x. What x could we? We definitely can't use 0, because we have the 1 over, would be 1 over 0 then, wouldn't it? But there's another values of x we can't use. What are those?
negatives.
Why not?
Because undefined.
Yeah, because you can't, 1 over a negative is negative, and you can't have log of a negative. So, in other words, what values of x can we use? If we can't use negative and 0, what can we use? Greater than 0. Not natural numbers quite, but greater than 0. Huh? No natural numbers, because we can have decimals. So,
Fractions and decimals.
Rational?
positive non-zero real numbers, or in other words, 0 to infinity. So whatever answer I get, I can only take answers between 0 and infinity. Okay? So Mo, you were asking me, how can you know?
Yeah, because in some other questions, wasn't the case. You cannot have 1 or 2 or 3. For example, I.
I?
Yeah.
Yeah, okay. So before I continue with this, I want us to have a look at I log 6 3x minus 2 log 6 2x plus 4 plus equals 1. Now, what is the restriction here? What values of x can I have? Well, I still need this to be positive, true? So I need 3x minus 2 to be positive. Can it be 0? No, can't have log of 0. And what do I need here? So, and I also need 2x plus 4 to be positive as well. So that means x needs to be greater than 2 over 3, and x needs to be greater than minus 4 over 2, which is minus 2. Okay? Now there's an and here. How can x be bigger than 2 over 3 and bigger than minus 2 at the same time? Well, we can get that if we say x is bigger than what? 3 over 2. If x is bigger than 3 over 2, is it... Well, no, someone confused me. Who said 3 over 2? 2 over 3. If x is bigger than 2 over 3, is it bigger than 2 over 3? Yes. If x is bigger than 2 over 3, is it bigger than minus 2? Yeah. So this is what we need for x. We need our answers to be bigger than 2 over 3. Just yeah, if there was a negative answer, definitely not then. This is what you're kind of asking me? Yeah. So if we go back to this question anyways, what should I do next? Next step. Any ideas?
X minus 1, and then you...
Okay, so we'll put in minus 1. Log 7x to the minus 1 plus log x7 equals 7. Bring down the power, yeah. And then after this, change which one? There are 2 logs here. The log x, yeah. So if you swap the x and the 7, what happens? 1 over. What's next?
Multiply by log 7x.
You multiply by log 7x. Minus log 7x squared plus 1 equals 7 log 7x. Right, I'm going to take everything to the right. So that would be something. Log 7x squared plus log 7 log 7x minus 1 equals 0. I doubt, no, this definitely doesn't have factors, does it? You can't have factors here. So I have to use my formula. Minus b plus or minus square root of b squared minus 4ac all over 2a. So my answer is x equals 7 power minus 7 plus or minus root 53 over 2, which you can put in on the calculator. Remember at the beginning I said x should be positive? Both these answers are positive, so I can take both answers. Yeah?
Yeah, you forgot the negative one though.
Did I?
Yeah.
Where?
The third line.
Third line?
Before the last. Before you start.
Here?
Yeah.
I forgot minus?
Yeah, minus. This is a minus log.
But I took everything to the right.
Yeah.
Yeah.
Oh yeah.
Why we didn't put the negative inside the bracket?
We can't. Why could we? Yeah, but if I have minus x and I multiply it by x, what would you say I have? Do you say I have minus x squared, or do you say I have minus x squared? First or the second? Which do you say we have? Correct. Now, if I multiplied minus x by minus x, I would have minus x squared. But I didn't multiply by minus log, I just multiplied by log. Yeah?
Sir, if you left it negative, you can still solve it, right?
Yes.
That's why I make
But, you know, it's good for your mental health to try and not use the calculator so much. So, you know. Okay, what are we having a look at next now?
4i, please.
Same page?
Yeah.
Okay. 4i on the same page, please. mind already?
Yeah. This is
3A. Okay, we're going to do 3A next. Can I scroll down?
Yeah.
Yep. 3A. 4 power 7x minus 7 equals 7 power minus 3x minus 6. Okay, what should I do first here? Simplify. Yeah, well, so what should I... Yeah, I suppose you could split the powers, but what do I like to do first here? I like to start off by putting in a log. So, everybody's calculator will have natural log. So what I can do is I can bring the powers down now. Yeah. Well, if you have another method, that's fine. Like, what would you think to do first? You mean like divide? This 7. And where does it move on to the left? Oh, okay, so you're saying something like this. Like this? Equals 0. Okay, and what would you do next then? Ah, no, I don't think we can do that. You want to bring the powers together? I don't think we have a rule from our powers that lets us do that. Yeah. So we'll go back to the original plan of putting log on both sides.
there is an easier way.
Go on, tell me then. Using your graphing calculator, is it?
No. Because if you bring it to the other side, then one of them has to have the power of 0, right?
Okay, you tell me then. What should I do?
Then, so like...
Bring what to what side?
If you did it like she was saying...
Okay. Like this?
Yeah, and then you would need one of the powers to become 0, right?
Why?
Because then you want 1 minus 1, so that way you have 0, correct?
Yeah, but you can also have 2 minus 2.
That's right.
But I do get what you're saying actually. 1 minus 1 is 0.
Yeah,
So you need these both to be the same.
exactly.
And one way to make them the same is that both these powers have to be 0. But it might not be possible to find an x that makes both powers 0.
1.
Hmm?
No.
Because like whatever makes this one 0, yeah, you can't make this one 0 at the same time. No, I do like ideas here. Ideas are good. If somebody has another idea to examine.
Just assumption. Not that idea.
No, it is an idea. It is an idea. Other ideas? I feel like people don't want to use logs here, but
Yeah, we'll use logs.
I can't see any other way other than using logs. Anyone? No? Okay, so shall we use logs then? So we put log on both sides, and now I can take the powers down. So the powers came down in front. Now I shall expand. So I get 7 log 4 x minus 7 log 4 equals minus 3 log 7 x minus 6 log 7. I'll take my x's to the left. So I have 7 log 4 of x plus 3 log 7 of x equals 7 log 4 minus 6 log 7. I took this guy to the right and this one to the left. Right, so next step, I'll factor out 7 log 4 plus 3 log 7 x because the x you can see is common, equals 7 log 4 minus 6 log 7, because here they're common. Last step, what's the thing to do at the end here? Yeah, so just I'll put a line through that and divide by it. That's the answer if you put down the calculator. Sometimes in the exam they actually ask you to leave the answer like this. What keyword might they put in the question to signal to you that they want the answer left like this? So what way would they state this? They would say,
The smallest,
they could say write the answer as blah blah blah, but if you just have to pick one word,
simplest form of logs.
that's not one word. Like what keyword could I ask? I could like say, I could say find the blank value of x. What word could I put here in the question that would mean to leave the answer like this and not to put it in on your calculator? Exact, yeah. Find the exact value of x. Now this is something that confuses students in the exam. A lot of students think in the question when they say exact it means decimal. So you were thinking that, weren't you? Yeah. And I'm sure someone over here and here was thinking that as well. Exact means the opposite to this, the not decimal answer.
Why?
Yeah. Okay. So look, the difference is, which answer is exact? The left or the right? The left.
Because it's repeated.
What? What would? No, that's fine. A lot of students would say right because they think the word exact means a decimal. But the reason it's not this is because you have to stop, don't you? You can't write the trees forever. So the moment you stop, it means your answer is not as good as this answer. So, but I do find, guys, I would say about 50% of students think the word exact means decimal. Huh? Yeah, if it said exact, you would lose a mark.
Sorry.
Yeah.
Would it be wrong to simplify that to minus 2 log 7?
Doesn't minus 2 log 7?
Yeah, because the 7 log 4 and 7 log 4, that's 1, right? Or,
I can't divide here
Can't divide.
because they're not being multiplied, they're being added and subtracted, so yeah.
See that?
Yeah.
What about changing the 7 to 4 power something?
no.
Sorry, what? It took me a second to readjust. We're back at the start thinking about other ways to do it. Okay. Changing the 7 into 4 power something would work. Do you want to do it that way? Yes, you do. So, we'll do this one again in a moment, the Amjad method. Is it? Yeah? Continue? Shall we see the Amjad method? Right, Amjad's going to tell us what to do. What one was this? 3A. No, wait, hold on, Amjad. We're not all as quick and smart as you. Just give me a second. 7x minus 7 equals 7 minus 3x minus 6. Okay, so it is a good idea and it will work. You have to change the 7 into a 4 with some mystery power, minus 3x minus 6. I see, still have to use logs though. So his method is right, but my point is you can't avoid not using logs. How can we figure out what number goes here? What can we put in on our calculator? Well, we're saying, yeah, 4 to what power equals 7. How do we figure that out on the calculator? By typing in what? Log what? What base? No. 4, 7. 4 to what power makes 7? What is that number, please?
1.4367.
7 then. Okay. Minus 3x minus 6. Now we'll have to multiply out the powers. So can you just do that number times 3 and then times 6, please? So it'll be minus
Negative 4.211.
211 x minus 6 times it. So that's about 10.
8.422.
And then so
Is that, yeah, well, what would you do next?
7x minus 7.
7x minus 7?
Yeah, is equal to.
Yeah, okay, so these are gone. 7x minus 7 equals minus 4.211x minus 8.422. So 7, 8, 9, 10, 11. 11.211x equals minus 1.422.
Yeah, 1.42.
Okay, so 11.211. What do you get here? Minus
Minus 0.1268.
0.
1268.
So 127. Now let's see what happens if we type this in on our calculator from the previous question. Let's see if we get the same answer.
It's like a difference of 2 decimals.
Fraction 7 log 4 minus 6 log 7. 7 log 4 plus 3 log 7. 127.
Pretty much the same.
Yeah, but not quite though.
No,
No. Listen, I said not quite. There's a small difference. So what is one disadvantage with Amjad's method? It's a wonderful method, but what is the disadvantage we must tell him?
Spend much time on the
No, that's not too bad. Yeah, the biggest disadvantage of your method is you can never get the exact answer.
Yeah.
You can only get a decimal answer. Do you understand? Which is fine, as long as the question does not say exact answer. Well, in this one I don't think I said that, did I? No. But I have seen it in the exam where they ask for the exact answer. Maybe 25% of the time for this. Yeah? Okay. This is good. What do we need next now?
Is this question B of the same for
3b,
3B?
yeah?
Can we use Amjad's method?
I don't like now that's called Amjad's method because I was just being silly about it. But fine, okay. Can we use Amjad's method? We can. Yeah, we can.
You can simplify to the power of 2.
Yeah, 4 would be 2 power something and 6 would be 2 power something. But that something would be a decimal. Yeah. Okay. What's next now?
6L.
6L. 6L. Looking interesting. Yeah, no, I like it. I'll say no more. I like the look of it. 6L. Well, I did make the question, so I should like the look of them. 6L. Log, yeah, this is a good one. Log base 16, 7x plus 4, minus log base 4, 8x plus 8 equals minus 1. Now, before I begin, let's figure out what values of x we can have in our answer. So, if I look at this guy, he needs 7x plus 4 to be positive. So, he requires x to be bigger than minus 4 over 7. Now, if I look at this guy, he requires 8x plus 8 to be positive. So that means x needs to be bigger than minus 1. Now, how can we have both? How can we have both x bigger than minus 1 and bigger than minus 4 over 7?
Bigger than minus 4 over 7.
Good, okay, so before we start, we need to say x is bigger than minus 4 over 7. And any answer which is not bigger than minus 4 over 7, we reject. It's not suitable. Okay, now on to solving. What should I do first? Change the base. Now, can somebody tell me why I can't just use rule number 2 of logs and say log A minus log B is log A over B? Not the same base. Yeah. Which base should we change, the 16 or the 4? Well, some people say 4, some people say 16. It's both the same. It's a little easier to change from a bigger base to a smaller base. You know.
Changing them to the 2 bases.
I could actually change both of them to 2. Yeah. But that sounds like a little bit more work. So I'll change them both to base. I'll change this to base 4. So what's the price you pay for changing the base? The price you pay is you divide by log of the old base. Okay, what is log 416? You don't need your calculator for that. 4 to what power? Don't. You don't. No. It's 2. 4 to the power of 2 makes 16. Right. What do I do next now? You have 2 choices. Yeah, let's multiply by 2. And then, what should I do next? Subtract? What do you mean?
Yes, like 7x plus 4 minus 8x plus 3. Divide.
Yeah. Wait, think carefully. What word are you saying? Divide? No. I can't divide because the 2.
I have to take the 2 up.
Yeah, I'll have to take the 2 up first before I can do anything else. So, the 2 goes up. Well, I can bring the 2 up and leave the minus alone, you know. So I can change it like this. I can bring the 2 up there. Like that. Alright, now.
Could you not bring the brackets to the front and to
Which brackets now?
it's okay, they're not hard.
Which ones?
8x plus 8 and 1
Ah, yeah. We can do something with that in a minute though. But what should I do next? What rule of logs could I use next? Bring down the 2. I just brought the 2 up. I should leave it alone. It's up there now. What should I do next?
Subtract.
Yeah, subtract. So I get log base 4, 7x plus 4 over 8x plus 8 squared. That should equal minus 2. Now it's getting interesting. So what's next? Expand the base. I don't even know what that means, but no. What's next? What's next? Well, just remember what logs mean, you know? You're saying that 4 to what power? 4 to what power? 4 to what power? 4 to the power minus 2. 4 to the power of minus 2 should equal this thing. So you can now say 4 to the minus 2 equals 7x plus 4 over 8x plus 8 squared. So you get 1 over 16 equals 7x plus 4 over 64x squared plus 128x plus 64 when you expand. So what's next? What should I do next? No, not yet. Could you though? What about the 7x plus 4?
We can cross multiply.
Cross multiply, yeah. So you get 64x squared plus 128x plus 64 equals 16 times 7. Is it 102? 16 times 7? 112. Okay, I trust you. Plus 64. Right. We're getting closer to an answer.
Oh my god.
You can see it coming, can't you? 64x squared, 128 minus 112 is 16? Yeah? Oh, and 64's cancel. And I can divide by 16. Can't I? Wonderful, all coming in place now. What's next?
4x plus 1.
Take out the x, I think, yeah. So that's 4x plus 1 equals 0.
And then 0 and negative 1 over 1.
Yeah, x equals 0 or... Now, are both answers acceptable? X needs to be bigger than minus 4 over 7, which is about minus a half. Yeah, both are fine. Both are fine. Huh? The minutes for this one? So this question finished at the 41 mark. So maybe it started at 31. It's an excellent question because it really makes sure that you understand what the heck you're doing with logs. So it's a really good revision question, you know. If you wanted to mark some question for you to try later in the year to see if you remember logs, that's a good one to mark. You know.
How many marks?
This would be a fairly big question in the exam. You know, it might be like 6 or 7 marks. 12. No. Maybe like 7 marks.
7 marks?
How many marks in total?
100 marks. 100. Out of 100%, this would be 7% maybe. Reasonable, I think. Normally what they do in the exam is they break this question up into 2 parts. So part 1 would be asking you to figure out this, and then part 2 would be asking you to solve. So it might be like 1 mark plus 6 marks in the structure.
Why is similar is what in the same, so we can try that later. Like, if you guys
Yeah, because you also have to change the base as well for that one. Yeah. Actually, let me just take the attendance here. Bum, 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 bum. Mahmoud is sick, isn't he? Gafar is also sick.
yeah, Gafar's in the hospital.
Yeah. Do we know how long he'll be in there?
He's gonna leave tomorrow, I think.
Okay. Amjad is here with his message. Zara? Oh, there you are. Mo? Unfortunately.
Oh.
What? Daniel? Yeah. Savi? Yep. Sabrina? Yep. Alfreda? Arya? Yep. Judy? Yes. I lost my sheet with my phonetic pronunciation on it is the problem. Young Peng? Amna? Yeah. Mariam? Oh, there you are. So I've got everybody. Wonderful. Before we finish, I'll just give you one more log question. You can try it at home. It's a tricky one that I gave the other students. Solve for exact x and y. Log base 6xy equals 36 and 2 power y minus x equals 1024. So it's a simultaneous problem. Simultaneous problem that involves both logs and powers. So that's a little one to do at home if you like, and if you want to see it done, it's at the end of the tutorial video from the previous class. So if you wanted to check your answer, it will be a decimal. It's not a whole number answer. You'll need to have square roots in it, so you can kind of guess that a quadratic formula will appear somewhere in this. Yeah. It's something for you to practice that's a little bit harder. Can I close it? Did you write this down? Yeah. Okay.
Can we just do y minus x is equal to 10?
Well, that's
That's
that's the step one, and continue. One sec, sorry.